All right, quiet on the stage. We are ready to go. Quiet, please, everyone. All right, if you could please stop speaking. We're about to go. Thank you. All right, so are we live? Oh, hi, everyone on the internet and everyone here. Welcome everybody to the launch of Rust 1.0. This has been like... This has been an amazing journey. I've really enjoyed working with all of you, and I'm really looking forward to all the amazing places that we are going to take this project. So in order to start the festivities tonight, there has been a video made that I would like to play for you all. All right, enjoy.
Rust is a programming language for systems programming, for applications that need a lot of control over the machine. They're very performance critical. Things like browsers and games and operating systems.
We give you the same performance as C++. We don't have a garbage collector. We don't have a large runtime. But we add the safety that you're used to from high-level languages. And that's a combination that is really unique.
It's meant to be totally memory safe.
It gives you a baseline of safety that you expect from other languages.
Kind of along the lines of like Ruby and Python and all those kinds of languages.
We have to show the world that memory safety is a big deal when you value this kind of correctness, keeping your users safe.
One of the big focuses of Rust has always been enabling parallel execution.
And it's designed to make parallelism and concurrency very easy.
Creating any new programming language, it's all really about trying to take the best that's out there and try to make it into a form that's easily usable.
The web is kind of the world's next operating system, and building an operating system is a systems task, and that is exactly where Rust is squarely aimed at.
People who are loyal to C++, they see C++'s strengths and they see no other language that really has those strengths, but they also see a lot of the downsides of C++. And I think Rust is one of the first really serious languages that keeps those strengths, but loses a lot of the downsides.
It brings something new and lets people do things that they haven't been able to do before.
Programming language model the way you are going to think about the problem. So when you learn a new programming language, you are enabling yourself to a different way of solving problems.
We actually designed Rust syntactically in terms of semantics to be very, very similar to C++. So if you take a look at Rust code and you actually already know C++ or C, kind of like that family of languages, you're actually pretty familiar with it as is.
Even if you know C++, you should learn Rust. Just become a better C++ programmer.
I've actually seen people say, I understand C++ a lot better after studying Rust.
Nowadays you should write modern C++, C++11, C++ 14. And what you'll notice is that if you write these new modern C++ dialects, you're almost approaching Rust.
It's somewhat easy to integrate C code with Rust. So you have like a C or C++ library, you can perfect well write a Rust wrapper for it and use it inside of Rust.
We've been working really hard developing the community hand in hand with the language, so by the time we hit 1.0, I feel like we actually have a really strong and vibrant community who's built up a large ecosystem.
It is very fun to be a part of a project and part of a community that is just coming up with brand new things all the time.
A community that's actually involved in the design, which is really important.
Everyone's opinion was being heard and everyone was able to participate.
A respectful place to be, like community. It's a very civil place where people's values are respected.
We've definitely had an overwhelming number of contributors even leading up to 1.0.
The way it has blown up, no one could have expected.
Like I've never been a part of a project that has grown so rapidly.
One thing that I'm a big fan of is Cargo, which is Rust's package manager.
If you know bundler in Ruby, for example, it's sort of the same kind of approach.
It's a centralized source for getting code, but anyone can publish to it, anyone can download from it.
We've tried to make it as easy as possible for people to share code and to sort of work between other kinds of applications.
Well, I think the single most important thing is going to be growing an ecosystem, quality libraries, and everything else. I think a lot of times adoption is really driven by convenience and factors beyond just the core language itself, but the environment around it.
There isn't such a dependency package management system like Rust has in Cargo.
I really think the niche for Rust that'll be most successful is for software that needs to be really ironclad, really robust, and really fast.
We're not stagnating. Once we hit 1.0, which is kind of the start of stability for Rust at the very least, it's not done. That's kind of the beginning for Rust.
Whenever you think you might want to use a low-level language, Rust is one of your options, but I think we've succeeded.
I'm really proud of how streamlined and smooth everything is today, and how easy it is to jump in and how easy it is to understand the language.
I hope that everyone enjoys using Rust as much as we have enjoyed creating it.
So now I would be more than happy to introduce Nico Matsakis from the core team on Rust. Please give him a warm welcome.
Well, hello, everybody. Welcome again to the 1.0 event. I think we've all been working pretty hard on this release, especially those of us kind of on the core team, and definitely all the people here who've been contributing and everything else. And we were hoping to start off this event with something a little lighter weight, something to kind of bring us back. You probably know Rust has been in development for a while, and we've accumulated a large history of interesting quirks. And I thought we would do a little trivia contest to take a look at some of those things that have come over time and see how well people know, see how many of you are familiar with them. So what we're going to do is we're going to go through a couple questions, and each one is a multiple choice, and I'll call people in the audience. And if you get it right, we've got some T-shirts in store that we can give to you as a reward. Yeah, a fancy new design just for this event. So the first question. Uh-oh, that's the wrong way. First question this way. What language was the first Rust compiler written in? Was it A, Haskell, B, OCaml, or C, Turbo Pascal? And I'm going to call on you. B. Yes, B, OCaml, that's right. So can you give your name to Brian here? Next question. What was the first RFC? And don't get your smartphones out. Was it private fields by default, the Rust RFC process, or the unified function call syntax? It's a tough one. Yeah? No, it was not B, although you might have thought so. Good choice, good guess. Zach over there? No, it was not C. All right, well, yes. And? No, oh yes, that's it. It's A. That's right. All right, which RFC received the most comments of all time? Was it the highly controversial topic of restricting /UXX to the ASCII subset, helpfully delineated here, or I/O and operating system reform, or renaming int and uint to anything else? Yeah, I think you raised your hand first. No, it was not C. Good guess, though. All right, Reem? Pretty sure it was B. Yes, it was B with 406 comments. Yeah, A got, I think, 1. Two. Okay.
B was 240.
Yeah. So B by a lot, in fact. All right, next question. What did this operator do? Did it swap two L values, or the contents of two L values, I guess I should say, broadcast messages to many processes, or abort the entire process altogether? Yeah. Yes, it was swapping two values. Now, this is a really hard one. You may know we've gone through a lot of keywords over time. We're at a pretty low point right now. So which of these was never a Rust keyword? Was it crust, A, or B, new, or C, alt? I think I already called on you one, so you in the green there? B, new. That's right, it was B. I was hoping that would take longer. So yeah, for reference, crust was the way you defined a function that was callable from C, a Rust function callable from C. It was a C to Rust function. Either our most inspired or least inspired choice. I'm not sure which. So the next, the hardest of all. Which of the following is an actual Rust acronym? You may know we have a predilection for acronyms. Is it POJO, Svine, or Imhetwama? Oh, Keegan is too easy. Anybody else? All right, Keegan.
It's Imhetwama.
That's right. It was Imhetwama. And what did it stand for the bonus points?
I have no idea.
It turns out it...
Java object.
All right. All right, Ben.
You wrote acronym wrong, actually. It's Imwatama.
Imhatpama, I think.
Yes, so it's actually none of those. So.
Well, it was first of all, it was Patrick who spelled it wrong. Secondly, yes, it actually stood for. And I think we're missing a letter on the slide. You're right, but imagine never hearing the phrase "aliasable mutable" again. But phrase got transmuted to words, and so P became a W. Yeah, that's right. All right, so that's the trivia. Congratulations to all the winners. And what I'd like to do now is to bring up the core team, and we're going to have a symbolic tagging of the release. It's going to be very dramatic. So come on up, guys, those of you who are on the core team. All right, so brief introductions. This is Aaron Turan, Patrick Walton, Alex Crichton, Brian Anderson, and Yehuda Katz. And we've also got, before we go on, we just want to point out we've officially launched the new governance model with the sub-teams. So in fact, the core team is only a part of the Rust leadership. There are also all these other fine people here on the language design teams and the library team, compiler, tooling and infrastructure, and moderation. So a big thank you to all of these people who are making Rust function. And now, without further ado, drum roll please. We're going to do it. And you have to make a loud noise when you do this.
And?
Oh, right. Did it work?
It went.
Okay. Very good. Very good. All right, then. I think that was very dramatic. So what we're going to do now for the rest of the evening is there are some lightning talks planned. And then are we going to cut the cake after the talks? Have you all seen the cake? Okay. What's that? It's a real cake, and we are going to eat it. I think we're going to do that after the lightning talks, though. So let's start the lightning talks. I guess I don't know who's speaking in what order, but all right, Patrick, you're up.
All right. Hi, everyone. So I'm going to talk just a little bit about Servo. For those who don't know, Servo is our browser project, browser engine project written in Rust. It's been moving right along, and we've been making a lot of progress lately. Here is, oh, great, this is actually rendered in Servo. Exciting. So this is the This Week in Servo blog. I highly recommend following it if you're interested in what we're working on. We got a lot of contributions. In fact, more contributions yesterday than fit on a GitHub page, which was great. I just counted the number of lines in Servo, counting all of the submodules, but not counting any generated code. It was, of Rust code, 461,000 lines of Rust code. So that's quite a bit. And that's not all just Servo. There's Hyper, OpenSSL bindings, all of that stuff that we couldn't have done without you. So there's a lot to go, but here are some additions. We have, it looks like there's some bugs in this one. Anyway, I know what most of them are. So WebGL, we have WebGL support. You can draw triangles now using WebGL in Servo. We have a lot of layout bugs fixed. We have support for every CSS property used by 50% or more of websites. And I can show some additional websites.
Space Jam.
We actually did land a fix for Space Jam. That was the background tag of HTML. And we also landed some other things that are used by sites that are really old and haven't adopted CSS yet, like Hacker News. Hacker News actually depends on Quirks mode in some ways that I can talk about over more drinks than I've had. And so this is what Hacker News looks like now. And we've also done work to make Reddit look really nice. You can... I'm not going to go to the Rust subreddit because, unfortunately, there have been some changes made that...
No, I checked. It works great on my machine.
Oh, really? Oh, okay. Yeah, so you can see the performance is pretty good with resizing. Yeah, that's actually using all your cores. And do we have a terminal?
Just minimized.
Oh, okay.
I think, yeah.
Yeah, so I can go to, we'll see how well this works. Well, it's a little broken. Oh, yeah, that looks great. Cool.
button on the right there, as you keep doing reflows, it'll keep getting taller.
Yeah, I noticed that. So we do have some bugs, but it's coming along very well. If you're interested, please feel free to get involved. Our DOM support is getting better every day. Our layout support is getting better every day, and it's starting to feel more like an actual browser.
All right, next up is Sean to talk about Hyper.
Is there any way to refresh? Because I was editing before.
What's that?
I was doing last minute edits, of course.
Yeah, you can.
Just refresh?
Yeah, just refresh. It should be on the internet.
Oh, yeah. All right. So I'm here to talk about Hyper, HTTP client and server library. Maybe some of you have seen it. But if not, does HTTP stuff. I'm Sean Monster on the internets. I work on Firefox accounts doing mostly server stuff, but I work in Node.js. So I've been working on Hyper because the goal is to eventually write server software in Rust, because we all want to write in Rust, right? So let's take a look at a simple server. You have a simple cargo.toml example. Excuse me, this is going to be technical in code. I hope everyone here is cool with that. And we add Hyper as a dependency. You got your main file doing some simple stuff and pulling in hypers, request response, so forth. The interesting part that we're going to look at there is the handler. In this case, it's a function that handles request and response. And we're going to do simple routing, right? So first, we're going to say, if we don't know this route, it's not found. But let's add an index route, right? Slash. So we add get, if, all that junk, slash. Then we can go ahead and send hello rest. And if we add another get slash by, we send by. It's kind of straightforward. This is what our program starts to look like. And eventually you start saying, hey, I want to add 10, 20, 30 routes. And that starts to suck. You want a router. And that's why we use routers, of course. And so we could use a framework, right? You could use Iron or Nickel or another one that I'm forgetting. But the question might be, well, how did they do this in the first place? And maybe you don't want everything that a framework gives you. You just want to add some routes. So we're going to show how you might do that. We may have a new create Hyper router. Of course, it depends on Hyper as well. We pull in Hyper, and we're going to be using a hash map, right, of methods, strings, and callbacks, which is just a closure in this case. Create a new one, new hash map, right? So here's where it gets interesting. And I had to be funny with the line wrapping, so it looks kind of crazy to me anyways. We have a function adding a method and a path, and CB is F function. I don't know how familiar everyone is with syntax. I'm just going to assume that you know everything. It's much easier for me. So we just go ahead and box that up into a callback and insert that into our hash map. And we can add some sugar functions, write, get, post, etc. that basically just call call add internally. But all of this doesn't show how the router actually works inside of Hyper. And that works by implementing the handler trait, which I'm showing here. And so we go ahead and impl handler for router, and currently does nothing. So the first part here is we're going to be matching first on URIs. And here's some info that you'd really only be interested in if you were making proxies or more complicated handling options and so forth. You're probably only interested in the path part. So we're only going to care if the URI is a path. If it's not, then you're not found. So in here, we're going to go ahead and look up with the method and the path, and look up a callback. And if it's not found, of course, it falls back to our not found. But if it is found, we get to call the callback with request, response, and unwrap it, which you should never do, ever. But I only have so much space in these slides. So we have our router. We get to pull it in as a dependency. And that handler function that we had, we're going to change it slightly, right? So instead of passing a function, we're going to actually create a handler and pass that into the function, into the HTTP server. And so here was the original handler that we had, and we'll go ahead and change it. We pull in the router, and we're changing handler to instead return a router, and it has no routes at the moment. So we add the first route, get slash, and we can pass in a callback. Get slash by, we can say by. And we could do dot post echo, and use some IO copy. What's wrong? You don't like post? All right. Use your router to put, delete, whatever you want. And so this was our original function, or our original library. This is what it changed to. And I went ahead and highlighted the slightly more interesting bits to see how the router might look in a full crate. And that's it. I think that's all the time I have, because I'm talking too much.
Please welcome Keegan, who's going to talk about the future of various things.
Maybe. Can you? How do I switch over? Mac. I can't use Macs. Come on. All right. So I'm going to talk about dependent types. This is a sort of has a fearsome reputation as like what you use when Haskell's type system isn't hardcore enough. But I'm going to try to argue that it's actually both simple conceptually and would be a really nice thing to have in Rust someday. So this is a far future thing, but well, let's see what we can do. So what does it actually mean to have dependent types? It means that types are first-class values, and it means that when you have a function argument, the type of an argument can depend on the values that came before it. So this function foo, it takes a type t, it takes a length n, and then it takes a vector, and the type of that vector includes the type and the length, the type of the element and the length of the vector. So this is pretty different from Rust as it exists today. So reasons we might want this, it simplifies the language a lot because we no longer have this distinction between type parameters, value parameters. It's all one level. And as we'll see later in this talk, not only is it simpler, but you can use this to prove correctness of your programs, almost any property you want. And that means you can even get rid of runtime checks. And as a nice bonus, Rust syntax for calling with both type and value arguments is really ugly. So we get rid of that because types are values, and that's just wonderful. So one way to do this that's pretty popular in industry compared to the others is refinement types. And this is basically where we can attach a Boolean condition to a type, saying, so here this I, we say I is a use size, but only subject to the constraint that I is less than the length of this slice. So this is a little syntactic sugar I've imagined, where you could say that essentially this where clause attaches to the type of the variable I. And the where syntax is already part of Rust, so that fits really nicely, and this is just like really easy to read, I think. To take a more complicated example, here's a function that defines the type of all numbers between low and high. So it's a function that takes two integers, returns a type, and I introduce a new keyword here called those, which is the introducer. So in traditional math syntax, this would be like, x1 I size where with a bar, and then the condition. But I think this reads a little nicer. And then we can say that a binary tree has a left subtree and a right subtree, and each of them is in the appropriate range. So once we have this tree type in the language, once we've written this tree type, then we know that every tree like this is going to be in search order, and the compiler will yell at us if we ever break that invariant. So that's pretty fancy, and it's not quite for free. This is an undecidable type system in the general case, and so most systems that go full on with this end up asking an off-the-shelf theorem prover like Z3. There's been a lot of progress in these systems in the past 15-ish years, and so they can often tell you, yes, that implication is true, no, that is impossible, but sometimes they don't know. And so one solution then is you could check at runtime. You can imagine in Rust we might even say check at runtime in debug builds, don't check at all in release builds. So that gives you a language where basically debug builds have a refinement type system. Release builds have an ordinary type system that is the erasure of those refinement types. And that'd be really cool. And there's one example of this. My TLS is a SSL TLS stack written in F# with refinement types. And they formalized a lot of their security properties, and they even found a bug in the SSL protocol in doing so, which is the triple handshake renegotiation bug. So this is comparatively a pretty well-tested approach that's being used for real stuff. The other thing, and maybe what more people think of when they say dependent types, is the classical type theory approach where we basically programs are proofs, which is this Curry-Howard correspondence that is just amazing. I don't have time to go into it, but you should read about it if you're interested in that. So programs are proofs. Programs are correct by construction. If you need to, you can just like return a proof that the result you returned is correct. So what this would look like in Rust is extending the enum syntax so that each variant of the enum can have its own type. So this enum is something you can already write. A natural number is either 0 or the successor of a natural number. You can write this today in Rust if you just remove everything after the colon on each line. But adopting that form lets us do some more powerful things. So this vector type now, rather than defining a vector in terms of like a property on the index, we define it inductively. So a vector is either empty, in which case its length is 0, or it is an element tacked onto another vector, in which case its length is the successor of the length of that vector. So just by saying this enum has this type, this enum constructor has this type, we build the knowledge of the length of the vector into the type itself. What's a little more remarkable about that is that this can actually encompass the whole refinements, arbitrary Boolean predicates too. So we can start with an enum. We can say that the type of proofs that A is equal to B has only one inhabitant, which is the proof that A is equal to A. And this is pretty mind-bending. It's like, how is this even useful? This enum only has one value named refl. There's no fields even. So at the value level, it's trivial. At the type level, it's extremely interesting because merely pattern matching on this word refl is going to cause the type system to perform unification between A and B. And I really don't have time to go into it. But essentially, this is really cool. And you can then just write out a refinement of T on some predicate P is a value T together with a proof that the predicate returns true. That's all it's saying, and it's kind of amazing that you can just write that and use it in real programming languages. So probably the most popular language for this now is Coq, and it is based heavily on these proof tactics. So fundamentally, you're writing your proofs as programs. They're like big, complicated pattern matches and stuff, and so people generally need help with that. So whether it's editors or proof tactics, that's usually part of a system. And what people often do is they'll write software in Coq and then translate it to Haskell or OCaml or Scheme. We actually have someone working on translation for Rust. It's certainly a better target than any other systems language out there. So yeah, dependent types for Rust. I mean, it would be great. It sounds like a fantasy right now, but given what we've accomplished in the past, decade-ish, like what will Rust look like in another decade, and what will the languages that it spawns look like? So yeah, I have some links. I don't have time to go through them, but you can look this up on my website, which is kmcallister.github.io, and you can click through to some of these papers and stuff. So this is a great textbook that goes through a lot of programming language foundations, and all the exercises are formalized in Coq. So every exercise in the textbook is basically like an interactive puzzle game with the computer, where you're casting spells and trying to use the next tactic, and it's telling you what you have left to do. So it's really a really engaging self-study experience. That book is awesome. These are all good too. Here are some more specific papers about sort of how could we use these in practical languages. So yeah, check it out. I don't think we have any time for questions, but you can come find me later if you want to talk about this.
All right. I really wasn't sure if you could do dependent types in 5 minutes, so it was impressive. All right. Next up is Paige from MaidSafe, an actual company trying to do stuff in Rust.
Hi, everyone. Thanks for having me. I'm Paige Peterson. I do communications, and I kind of work on MaidSafe's website, redoing it right now. But the company itself is based in Scotland, and I'm the only one in the U.S., so I'm kind of doing communications for reaching out to various communities and whatnot. So I wanted to kind of give a really brief intro of what the technology that we're building. So we're trying to essentially build a platform for decentralizing storage and communications. It can be seen as sort of an alternative internet of sorts that removes dependence on servers. So instead of saving data and using servers for communication routing, you are instead using individuals' nodes hosted by users of the network themselves. So it's kind of this large project that has been in the works for over almost a decade now, doing a lot of research and development at the early stages, and kind of coming into feeling more comfortable with building the different libraries and whatnot. And so we've been doing a lot of outreach to different communities, but this is a really exciting community for us to reach out to. We did originally write the core libraries in C++, and earlier this year decided to make the full switch over to Rust. We completely deleted our C++ libraries. You can't find them anymore, as far as I know. There is a lot of other things we did when we switched over, so they wouldn't really have been compatible anyway. But yeah, so essentially what we're building is this platform that we're trying to have be the focus on privacy and security. So the users that will be using this will be looking for a system that will save their data in a secure manner and keep their identity private. So I'm not going to go into the technology stuff. I think we're going to plan to do a longer talk at a future Rust meetup, so I can talk a little bit more about the technology, but just to show kind of the stack. So we're building literally everything on top of IP. We have our own crust. That is, it's called, it stands for connections in Rust. So it's going to be this layer for just kind of going out. And all of these different layers are going to be their own libraries, or are their own libraries. So you can right now go into just search MadeSafe, and you can see the different things that we've built. You can even download some of these and start working with them, like the self-encryption tool. It'll essentially, it's part of the network, but it'll essentially take any file that you want to encrypt. It chops it up into chunks and encrypts those chunks and creates a data map. That data map will be secured on the network, but that's just one component, and you can begin to start playing with all of these things. We aren't completely kind of migrated over. We're still figuring out a bunch of things. We're still honestly building out the network as well, so there's a lot of considerations that we're running into that aren't necessarily Rust related. So I guess I kind of wanted to share a quote that I found one of the founder, David, said in one of the Slack channels that I think kind of encapsulates the need for Rust, at least in our situation. This was in context, like just one of the developers was having a little problems with doing some of the testing with Rust, and he was wanting to like see if there was a way to modify the testing. He was like, they will run in parallel, so we need to work with that. We cannot short circuit alter the system of test builds, so we need to just work harder to test. Otherwise, we go back to the land of spaghetti and complexity where nobody knows what's happening, and we're not going back there. So this is, I think, just, I think generally Rust is a really exciting thing for a platform like MadeSafe because we're working with a lot of different components. And additionally, in addition to, you know, our interest in building a decentralized internet, it kind of maps onto our interest in the development process. So we want outside developers to partake as much as possible. We want we've already had a few contributors from the Rust community kind of help clean up some code and whatnot. But the biggest thing for us is not to be the sole owners of this potentially alternate internet. So we want outside developers to participate, and Rust is we think a really great avenue for that in terms of making it more accessible compared to C++. Yeah, and I guess just to note that we're also all of our code is GPL3. So if that excites you, then we're definitely interested in that. We're also having some internal debates about whether to stick with that or not. But we do generally want to make this and use Rust to build like this alternate internet that is focused on privacy and security. And then I guess finally, if you want any t-shirts or stickers, there's some t-shirts and stickers over there. It's only small through large, but next meetup I'll bring other sizes if those don't fit you. All right, thanks.
All right. Thank you, Paige. So we actually have now Matthew and Rachel, or just Matthew? It's Matt. Okay. From yet another company that's forming around Rust, Ironworks.
Can I get slides?
Oh, yeah. So demanding. Okay.
Awesome. Happy 1.0, everybody. It's exciting to be here. Thanks to Eric, and super thanks to the core team for making this happen, and of course all contributors as well. We're the Ironworks company. We have a background in network and systems consulting, and we just came off of a 3-week Rust project, and it was one of the most productive and interesting 3-week projects that we've done as a team. And we built another security, privacy-focused library based around Whisper Systems axolotl ratchet. So I'm going to talk a little bit about that. I'm going to give a little bit of background first. So back in 2013, we were involved in some of the heavy lifting behind Signal iOS. And Signal iOS is an end-to-end encrypted voice and text messaging platform. It's free. It's available on iOS. There's a Java implementation available for Android, and it's pretty good. I really would recommend everybody here use it. It's one of the really interesting things about privacy and encryption is that the more people use it, the more herd immunity everyone has. So this work finished up for us in late 2014. But more recently, Whisper Systems has launched the axolotl ratchet. And it's a modern protocol for asynchronous communication with some interesting privacy and security guarantees. So it's got forward and future secrecy. And what that means is that if there's a key compromise at a moment of time, only the messages that are using that key will be potentially breakable. Historical messages, the keys to those are gone. And future messages are going to be ratcheted on that existing key. So the key you have is actually not enough to read future messages. It's a really interesting protocol. There's some people who are pushing to have it used to be really ambitious and replace GPG as the gold standard for kind of general purpose communication. We really want to see it used more places. And so when we came to this, when the protocol launched, we thought to ourselves, okay, we want to help build this and make it a general purpose library. But writing security software in C is really scary. You can write it, you can get lots of eyes on it, you can think you've done a great job, and then, something comes up, and we're great programmers, but we're not superhero programmers like the, LibreSSL guys, so I don't think we're going to do it right. But Rust makes this possible for normal human beings to solve some of the significant security, some of the problems that have faced security applications over the past decades. Right off the bat, the bound checking errors, the read after free errors, the buffer overflow errors, all the classic errors gone, which is pretty awesome. But as bonus points, Rust makes it pretty easy to do some basic compile time checking of your protocol. You get strong typing on your crypto primitives, so you can be sure that a public key is never mixed up with a private key, that ciphertext and plain text are never crossing paths when they shouldn't be. You get enforced match coverage. So if an error is thrown from some part of your program, the compiler demands that you handle that properly, which is great for the first implementation, but which is even better as the library is maintained, developed, extended. You're not going to have another committer come on board, make a change, have an error that previously was handled no longer be handled. That's really interesting. A bunch of other kind of littler things, especially when you're using block ciphers, having fixed length arrays as compile time guaranteed, super useful. All of the code for this is, I guess, up on GitHub. I'm not going to do any code examples right now, but I'd actually be happy to go over that on GitHub with anybody who's interested this evening. One thing that would be really useful is we are learning Rust as we go. I think as many people are. We're particularly interested if folks have comments on what we could have done more idiomatically. We kind of came to it with a lot of experience in C#, a lot of experience in C, C++. I'd imagine we did a lot of things in ways that Rust could do better, and we'd love to hear some feedback about that. We're pretty excited about Rust. We think this is going to be the tool that's going to make interesting things for the next 5 or 10 years. I'd love to hear from folks here. Why aren't you using Rust for your next systems or networking product? I'd love to hear that. I'd love to hear what those obstacles are, and I'd like to figure out if there's some way we can help tear those down. Come chat with us. I'll be around. My business partner Rachel's here. We'd love to hear about problems with the language, ways we could help with the ecosystem, ideas for products. Interesting stuff. Thanks, guys.
All right. Thank you. So next up we have Zack and Joe from terminal.com.
Hi everybody, we're really excited to tell you about how we use Rust in production today at terminal.com. So let me tell you a little bit about terminal.com first. So we have tens of thousands of users and followers using our really fast, really easy to use cloud. We can launch a full virtual machine in seconds. One cool feature we have that other clouds don't have is we can take a running machine and snapshot its full RAM and disk state, so you can start it up with all the services running really quickly. And people really love our cloud for data science. They start up 10, 100,000 node Spark clusters, and they all have to talk to each other really securely and really quickly. And that's what the talk's about. Our old generation networking system was based on a bunch of C code and basically had to manage a large number of machines always migrating, moving around on our physical hosts. And they're always starting, stopping, pausing. Just a lot of moving parts to manage. We had a very simple system that it was just difficult to extend and difficult to get more junior engineers to work on without potentially causing some instability. And it was all closed source. So we're moving over to Rust and open sourcing everything and hoping that people can contribute and use it more. And I think we'll have something that's extremely extensible and something that a lot of other people can build on. So why aren't we using Go or Python or Java or something that didn't reach 1.0 today? We're a systems company. We're running really fast systems. People don't want to compromise on the speed. The GC is going to pause. We're not going to get the memory that we want. Basically, any of these GC languages aren't really going to work. Also, we're not going to put Java in the kernel. C and C++ work a lot better. The problem is, C is a little simple, doesn't have the rich type system. C++ is getting a little bit better, but it's quite complicated, it has a lot of baggage. And in the end, as careful as I am, it can crash. And that's really unacceptable when we're a substrate layer for all of you users. So why are we using Rust instead? Well, it means we can take these junior engineers who are used to Go and Python and GC languages and get them to be productive really quickly. And the senior engineers who have a lot of experience about making sure to be careful about memory management, they don't have to spend their whole time when reviewing code, oh, did you think about this? Did you think about this? I can just the engineers can just focus on high level. Is this algorithm correct? Is this the right data structure? And the compiler, thank you, Rust compiler developers, does that for me. And it saves an enormous amount of time. But we're a startup, we need to move fast. And when the compiler is teaching people how to think, that's really great. And also, I mean, the Rust community is really great, really, really genius, and really nice. Okay, so what are some downsides? Language has been changing quickly, a lot less now that we're 1.0. That's really great, but it's also forced us to have a lot of automated tests, which are valuable in and of themselves. There isn't a lot of library support. We had to wrap a lot of C libraries ourselves and create them, but that's great. We get to contribute to the open source community. Rust BindGen is a really cool program to automatically generate these. And the last point is there is a steep learning curve that's absolutely potentially a downside. The way we look at it is it's a training tool for thinking. So again, like if someone isn't really a top modern C++ developer and they have only used GC languages, like they need to learn all those skills, all those little gotchas. And the Rust compiler, again, teaches our engineers, like, here's how you can think about it. And thus we get a lot more productive team a lot more quickly. Okay, so one of the things we built is something that watches every packet that's leaving our cluster, and in less than half a second can detect and stop like port scanners of using our system to launch attacks. We have a C version of this. The Rust version runs equally fast, thank you, zero cost abstractions, and we saturate a link, so there's no slowdown that you might get in other languages.
So the way we do this, we need to make a lot of system calls. So, and we had some help, and we wrote an abstraction over netfilterq, which is itself an abstraction over the netlink library in C. And we also wrapped some kernel calls. And those FFIs are pretty easy to do, and they are on crates.io now. And we also started to re-implement an optimized 2-level LRU cache in pure Rust. So it's a work in progress. We'd love it if anyone would love to look at it, also on crates.io. And our firewall is in production and working right now. Moving forward, we would also like any packets that go between our terminals to be filtered explicitly if they are not allowed to go between those terminals. And we want to do that by storing them in a cache and looking up those that we're not sure of their permissions using a source of truth in Redis. We hope this will eventually be faster than IP tables in the kernel. So the way that we're doing this is we're using Mio, which is great. I recommend it if you haven't looked at it. And we also adapted the thread pool to keep open Redis connections. So it's published as Redis pool. And that way we have open Redis connections and we avoid the overhead of reopening those connections every time we make a query. So once this is operational and good, it will be open source as well. The best part of this is that the easy thing here was the multi-threading. The hard thing was the logic, which is great. It's great that there's a language that lets us do that. Moving forward, we'd love it if someone would talk to us about binary size. It's still much larger than our C counterpart, even though it does about the same thing. We also would really like to move this into the kernel and get it a lot faster. There's examples out there for it. It looks really cool. We have a lot of work to do. We'd love to talk to you guys. We're hiring too. And stay in touch.
All right. Next up, we have Sam, who wants to talk a little bit about 3D stuff. I don't think I have a black screen for you.
I know. Can I just plug that in?
Oh, yes.
Let me take this. Thank you. Is it gonna work? Oh no, it's huge. There you go. Hey everybody, my name's Sam Ward. I just wanted to quickly show you the state of 3D programming in Rust. It's a very, very exciting opportunity to do open source programming for 3D, and basically just wanted to expound on that a little bit. Who here has actually written a game programming in any programming language before? Who here has written a 3D game? So there are a few people. Rust has an amazing, amazing potential to become the next open source 3D programming language. There's actually a lot of activity in the community already, even though we're just announcing 1.0 today. There are full engines that have already been written in Rust. For example, Piston is the most popular one, I believe. I don't have slides. I'm just going to show you a couple open source projects that are out there right now and try and get you excited about it. Basically, even if you're new to game programming, then Rust is creating opportunities for people to learn how to do it very quickly, and essentially, in the future, I think it'll be possible to make entirely like AAA quality games entirely in Rust. And the reason for that is it's easy to write safe code. It's easy to write fast code because of zero-cost abstractions, and the interlocking capacity of generic code will make it possible to sort of like mix and match different components of a 3D stack into a game or a 3D thing of some kind. So Piston is an example of a full engine that's already been written. There are already games written in Piston. For example, a Minecraft clone called Hematite. This is written in Rust. It's completely open source. It imports files that run in Minecraft, and just it's Minecraft in Rust. So you can start using Engine right away, or you could take a look at some other attempts for engines and mix and match some components that are available right now to try and make your own, which sounds like a Herculean effort. But it's actually becoming quite possible to do by yourself. For example, a very smart man named Sebastian Crozet has written these N libraries, N physics, N algebra, N collide, which for the most part take care of collision detection, linear algebra, and he also has some rendering stuff out there. But they are components, which is very interesting. You can mix and match them to make your own engine. For example, you could write an entity component system that just kind of takes in this physics library or grabs this rendering library, mixes them together, write your own entity component system on top of that, and boom, you have a fully featured 3D engine already by yourself. That is a very good question, and I don't know. So here's a demo of NPhysics. So there you go. It's slowed down because this was a stress test, but let's just do the first one. Completely written in Rust. If you just want to hack something together really quickly, there's libraries like Kiss3D, which will allow you to just throw together like literally 20 lines of code, I think, ish, and boom, you're up and running with a fully 3D program that runs on OpenGL. A lot of this was possible because of Servo, actually. Servo uses OpenGL, and so they wrote the bindings that are currently used in most of this. Although, there are other bindings available. There is Gluten, which is a pure Rust alternative to GLFW, which is a common C++ binding. And other interesting things exist, like Glassful, which is I believe, a macro system for shaders. So you can actually have shaders in your program also, entirely within Rust, which is very cool. So yeah, I hope that got you a little bit interested or excited about 3D programming in Rust. It's a huge opportunity. I believe that we could have this ecosystem that's better than any other 3D ecosystem that's out there right now, and I'm very excited about it. So I was hoping to spread the excitement a little bit and get you interested. Go on GitHub, look for Rust 3D, look for blog posts. It's actually a very active sub-community within Rust, and I believe it's going to explode in popularity and become very, very big. Thank you.
Thank you. So also, coincidentally, after we wrap up here, I actually have Hermitite and a couple of the other 3D things on my laptop that we can show off. So to close out our lightning talks, we have Ben Striegel.
How's that? Wait. Oh, hold on.
Oh, do you have
It's
a mouse?
been. There we go. All right. it works. So hi, I'm Ben Striegel, and basically Eric asked me to give a talk. You saw me in the video, I'm the crazy rainbow guy. I kind of fell into Rust in about 2011, just totally stumbled into the community. It was a very nascent experience back then. The language itself was a very different language, and so my idea for a talk was to kind of give a demonstration of how different it was in 5 minutes. And I came up with this list of things, and it's a very long list, and each of these could all on their own be a lightning talk about Rust, and there is actually crust in here, so to continue the theme tonight. And then I started really looking in, and I saw that there were things that I hadn't even known myself about, and I really want to kind of express how different the language is, and how amazing it's been to watch it evolve over the past 4 years or more. So, as you may know, the language itself came from originally a single man, Graydon Hoare, who I'm hoping is watching. Hi, Graydon. And he started in about 2006 on his own time, but eventually in about 2010 or so, Mozilla started picking it up and actually paying him, I think Patrick and Brian, as well, to start actually working on it full term. And it was a very different language back then, but I want to emphasize how the goals are really what drove this language. It wasn't really, we have an idea for a feature, or we have an idea for what we want. It's kind of where we want to end up. Let's now figure out how to get there. So, helpfully, Brian wrote a while back a tool that lets you actually explore the test suite from Rust, kind of by stepping through time and seeing how things have changed over time. And you can just play and watch it go, and many of these tests don't even actually make sense in modern Rust, which is why they're exfil today, and it only goes to 2012, 2013 or so. But if you look at these, it's just none of those things on my list that I showed you before are actually mentioned at all. I want to show you this next slide right here. So this here is Rust code circa about 2010, middle of 2010. As you can see here, we have a notion of purity. We have this function does IO. It was not pure by default. We have generics with square bracket syntax. We have types coming before the names. We have first-class channels in the language. We have kind of a Go-like channel receiving operator. We have logging with log levels controlled by environment variables in the language itself. We have type state, which is kind of a really wacky feature that is really cool when people are sad that it's gone nowadays sometimes. And we have more. I don't even know what this does. Does anyone remember? Can anyone even guess?
It must be a channel send.
Is it a channel send? Okay. Probably. So this is an actual test case. This is from, and I want to emphasize, pretty much none of this is in the language anymore. So functions, yeah, FN is there. We still have the two-letter function. Excuse me. So, and we can come out into here, and we can look at this one. This one has this one is the COM, and we can come here and see. And we can here's the original version of it, and we can watch. So IO becomes impure. Then we exfil it because it failed, and we never actually probably turned it back on. And then, FN main. And then when the check goes assert, and various things continue happening. And you can just play with this tool. I can give you the address to play with it. It's called Archia, and it wasn't updated, it lasted in 2013, I think. So it doesn't quite go to the modern day, but it's a really fascinating way to look at these things. I can show you some more too. So this next one here is, has anyone heard of iterators before? I didn't realize this until actually when I went to talk together, is that we used to have iterators in the language as a first-class feature. And apparently at some point we lost them. This iter function here has a yield construct called put. And then we had a for each construct. And no one knew about this, apparently, except for Graydon and possibly Brian and Patrick, and they didn't tell any of us. And then we also have, for example, you can see here a very strange indexing syntax with just a dot parentheses to index into something. And we also have interior mutability, where mutability is not part of the slot, it's part of the type. And I remember this, because remember how much of a pain in the butt it was to remove from the language after a while. And this isn't to denigrate anyone's efforts from back then, because it's kind of just to emphasize how it's very experimental and how we've focused the language so much over the past few years. And I could just write a book entirely on just the evolution of things. And I'm sure if you're a language designer or an aspiring one, you would definitely benefit from reading it. And here's some more right here. For example, so you used to make tuples with this tup keyword, and then we had tuple indexing. This is back in 2011. This is before my time, definitely. And if you have used Rust in the past year, remember we didn't used to have tuple indexing. We actually removed this feature, which is because, I'm going to show you here an actual next evolution of this piece of code. Tuples were removed in favor of anonymous structs. So kind of like an Erlang-style record, almost. And then you can still index it, but then eventually we implemented the trait system, which didn't play well with anonymous structs, so we removed these entirely and then didn't give tuple indexing to the actual tuples that we still had in the type system. And so it's kind of, I want to emphasize here how features themselves come and go, but they're always considered in the service of whatever is currently, we're experimenting with trying to figure out what is the best fit for the language. And so a lot of Rust evolution has been take one feature out and then realize that like 6 other features are suddenly redundant or unnecessary, and then we remove all those, and then it's this cascading sequence of events where language, like in like the course of 6 months, becomes entirely recognizable. And as you can see here, so I think the FN is still there, but we have like the assert, we grew a macro system, so assert didn't need to be a language feature or a keyword, so now it's a macro. We have log, again, log also, I think it's log a macro, or is now it's like a crate somewhere? I don't even know anymore. It used to be a macro. I lost track. Right, and so it's really fascinating to see how Rust is just adds features and removes them, and then also, for example, we don't always just go back and add features back in. So, for example, here we have an example of partial application, which used to be in the this is what we're doing, right? It's partially applying this, right? I had to guess. So, is that a managed function box? Yes, it is. This is the old closure type syntax, which was after the FN for grammar reasons, if I remember, and we all really hated it. No, it was FNat. It's really older than that. You have no idea. And I'm kind of just, I know it's kind of just we have like a laugh at it, but it's in the moment you look at all this stuff and it's kind of like you're really caught up in it and you're saying, hey, this is a really great idea. And some people are kind of like, well, how do we know that like now 1.0 is the right time to stop evolving, and language is fine, it's good enough? And the answer is we've tried pretty much everything. We're out of features. So now's the time. So if you want to check out Archia, I can ignore this. The word auto is here. I don't know what it's for. I was just baffled. What is this? And to finish off, I wanted to show you the progression of Hello World from the beginning of time. It's not super long. We had log, and then something like grumpy. Then we're the old macro syntax with hash debug. I'm not sure why we had debug. And then new macro syntax became a function, and then became a function that was imported by default, and then it became an actual macro again. And that's pretty much it. So thank you, everyone.
All right, thank you, Ben. All right, this has been a pleasure. I've really enjoyed working with all of you, and I really look forward to working with all of you for the next decades. So anyway, we have cake. Internet, I'm sorry, we don't have cake for you. Have a virtual emoji cake for us. So for the rest of us, we have the space until Mozilla kicks us out. So please enjoy the rest of the night, and thank you so much for participating. All right, good night. Okay.